Hi guys, and welcome here. It's always a hit and miss with the presentations, going to a conference to see if we get 2 people in the audience or if we get a nice bunch like we have today. We'll take a trip down the memory lane a bit today, talking about the event-driven architecture from what I did 20 years ago and why that might still be relevant today. So a little bit about me. That's a long text. Let's give you a little TLDR. I like things that beeps and boops, and especially if it does it automatically. I can also let you in on a secret. When you're on conferences like this, even the big ones, I'll say more than half of the presenters on stage suffer from a bad case of imposter syndrome. And probably a lot of you know a lot more than some of us, but maybe we can at least give you some ideas, let you learn from our experiences. Yeah, so yeah, my ADHD sends me down some interesting rabbit holes, ends up me submitting to my abstracts to conferences, and suddenly I have to go and stand here. Always feel not very prepared until I'm here. And then I love it. So, this is the oldest snapshot I can find from my first ever website, or that was my company back in the early 2000s. This is from January of 2007. I think my first version was launched at least a couple of years before 2005 to maybe late 2005. And I think this actually is the second version, but this is the first that's on Wayback Machine. Of course, I don't have anything myself. Sadly enough, some at this conference are maybe too young to even have like conscious memories from this time. So yeah, I'm that old. So this was from the time where SMS was pretty expensive. But it was starting to kind of getting traction between the young people. Usually they had like limited plans with a limited amount of text messages each month, or very expensive per message. But people did not have a lot of experience of how it worked, or they did not have blocks against premium services. That's where we come into the picture and actually made some money. But I can promise you prices were pretty reasonable. We just provided a bit less expensive solutions that they got. So in the first version, just to give you kind of the backstory of why we ended up where we did. All messages, or everything, was based on a SQL database. All messages in the systems were like inserted into a big table, and we had this huge, mighty transactional SQL, SQL that was triggered on like a schedule. And I don't even know if any of you have any experiences with pointers or cursors, what they're called in TSQL. It's very inefficient. You generally have no idea what they're doing, and it's terrible to debug. But you know what else was possible in transactional SQL at that time? HTTP requests directly from your database. Because you could initialize COM objects from Windows and on your Windows servers. And most of the suppliers offered like HTTP-based APIs, so we could actually do anything in SQL. So the whole SMS gateway platform was just one huge transactional SQL script. So, who needs another programming language, or any integration platform for that sake? And who thinks we might have run into some hard limitations doing this? So at a point, you're kind of just standing there looking at your mess, and yeah, most of the pictures are just Midjourney AI generated. I have 60 slides to get through in 45 minutes. So, but yeah, you're just standing there, realizing it's a bit inefficient. You can't handle everything that's getting thrown at the system. You're getting congestions in the both in the ways in and in the way out. And yes, there was something we could do. We did some like working with the right indexes in your SQL, truncating, moving, archiving, etc. But it's still so much you can do, and that's kind of a band-aid on the problem. And here you also see the big problem with AI. This is the best I could get of a band-aid. I tried, I promise. AI doesn't know what a band-aid is. I tried even more. That was terrible. Let's get back on track. So yeah, we had this total mess of sending HTTP requests in the world's biggest and ugliest transactional SQL function or method. So there I was, nerdy, naive, fresh junior from school, thinking I must be able to solve this in another way. Maybe I can do it programmatically? But how? Like my experience from schools was with Windows Forms applications in .NET 1.1. And some ASP.NET web forms. That was before MVC was a thing. You can feel the pain. And now we're kind of getting back to the web forms. I don't understand why in the new frameworks as well. Sometimes we just go full circle. But I was thinking if we could take the messages from the website, send it to another server application, and yes, we had bare metal, that was what we had. No virtualization. We had our OS installed on the server. If you had to fix something, you went to the server center. It was extremely noisy and very cold. Or they had some remote access cards that actually worked. You see how I wrote this manuscript when my ADHD medication had run out? I'm kind of getting all over the place. So let's make this server do some magic, send it to the provider. We still need the database. We still need to be able to like process invoicing and everything like that. But can it just be the log instead? And like not having the database as the central integration hub. And this was kind of the start of my integration journey, and I've been there since then. So it was something that was kind of cool, and how to run your automated things back then. I find traces of it back to 97, 98. Might have been there for a bit longer. I did this early 2000. But it started kind of being the pinnacle of how you run your services on Windows Server. It's called the NT services at that time, now renamed to Windows Services. And yes, it still exists today. This is a screenshot from my home computer. We still have the services running in the background. Was it the best? Probably not, but it was pretty widely used. It was quick to make. It was easy. You got the overview. It was easy to restart your services, as long as you could log into the server, of course. And of course, this ran on one single server. It was not a cluster. It was not virtualization. And again, we're talking about bare metal. And yes, that really came back and bit me in the ass at a later point. We'll circle back to that later. And then we got the task scheduler. That was the other. Windows answer to cron jobs in Linux. And yes, this also still exists. This is from the same computer. Took a screenshot before I left home. Because I had to do it at home, because on my work computer I'm actually running my Linux system, even though I'm 100% Microsoft developer. I've been in Azure since that was launched in 2011-12. But yeah, there's one more thing I needed in order to create my design in the early 2000s, and that was also launched with Windows NT 4.0 in 1997. That will really help me along. So if you take a look at this Information Week news article from the March of 1998, we can see we have a Microsoft MessageQueuing server. It was introduced in 1997. Also touched upon something called the global atom table in Windows that allows you to set some variables that are accessible through all services. That made it possible to do a kind of control shutdown of everything, since we were running on one server anyway. So now I just had to build the scaffolding. I had all the building blocks I needed. So now it was only a matter of how we're putting this together. So this is pulled from my memory of something I made 20 years ago. I'm probably skipping something. Go easy on me. But we have the website sending everything into SMS empty mobile terminated. SMS going to a phone. Through Microsoft MessageQueuing, still used like the database for logging, but that was archiving. So all the services sent a copy of the process message to the archive service. We had the routing handler, we had the providers, and of course also that sent everything back to the archive handler. The only thing we had to be worry about here was the archiving service, because we can really get some backups here because the limitations of the SQL server, but that was generally not a problem. Let me get my pointer back on my own screen. There we go. And all of these Windows services had an internal thread pool, so it actually did scaling when it needed to. And I was really, really proud of this solution. And I made this design because I found stuff in the framework that worked for what I was going to do. And with .NET being pretty new, I found out they had thread pooling that was kind of automatically scaling and firing off new threads whenever needed it. So I really thought I made something new and really exciting and cool. And then it turned out someone else found out before me. So I reinvented staged event-driven architecture without even knowing it existed. So kind of reinventing the wheel without knowing there existed the wheel. But still, I'm pretty damn proud of it, though, because I didn't know about it. So with this, our bottleneck was not within my servers. It was generally in the provider's domain. The microservices were rocket fast. They were scalable-ish. Within that one server. It was efficient, and database storage was asynchronously. Yes, we had congestion issues with storing to the database, but it's kind of an acceptable risk at that point. Since the messages were on the queue waiting anyway, so they were processed during non-peak, no rush there. And of course, there were some weaknesses. The Microsoft MessageQueuing was not persistent, meaning if we got a crash, power outage, even a reboot or some internal crashes, it will kind of empty my queues. But again, acceptable risk. Everything was generally being sent out. We didn't have a loss in traffic. The only thing I could miss was some logging and maybe it was some messages we wouldn't get like paid for, but we had pretty good margins. So it's kind of how much effort are you going to put into saving just a few pennies anyway. So now everything was just sunshine and rainbows, and the rest of that is history. But I talked about the issues of running everything on one single server. Even my database, my website, and all my services was running on that one bare metal. And of course, with one single disk. And I'm sorry, we're in DevOps days, but you can maybe imagine how good I was at DevOpsing as a junior developer. And GitHub was launched in 2008, so this was way before GitHub anyway. So anybody see where this is going? Waking up one morning, we had one of these spinning thingies. I was kind of not spinning anymore. Getting to work, server is 100% unresponsive. Getting in the car, getting to the service center, locking myself into the cold and noisy room, find my server, and it doesn't even turn on. I just get a message, cannot find disk. And how much backup do you think I had? So next server had the RAID controller, at least, and backups. That was almost the downfall of my whole company. I was actually able to recreate most of the data using other sources, since all of my my messages was going somewhere, so I could like get their phone numbers back from the vendor. It was a total disaster. Now I learned that DevOps exists and backups exist and clusters, and we're not solely depending on that one single server. So let's have a little history lesson. What defines an event-based architecture? Is it microservices? Is that new? I mean, in the 2000s, it was considered something new. This is kind of the general consensus of the timeline of microservices. They came kind of in the early 2000s. They say like 2001, 2002. And then kind of emerging into the web services in 2010, going up until today. But what is this then? This is from the launch of the Unix operating system in 1982, talking about how you could have small programs that you're piping information in between, like microservices. It's a cool video. It's like half an hour long, talking about all the new and cool things in Unix and how everybody could be a programmer, just like we were talking about community programmers today in low code, but let's not go there. So it's all about perspective, right? With what glasses are you actually looking at the facts? We can go in further back. Maybe not this far. This is Ada Lovelace, for those who don't know. She grabbed Charles Babbage's difference engine number 2. He made this like statically to do some calculations. Ada Lovelace was the first one that discovered we can actually make this do other things. We can program it. So the inventor of computer programming in 1843. But let's not go that far. But we can go to the 40s, 1940s. When Konrad Zuse, a German, invented what's considered to be the first programming language, it was called, I need to read that, Plankalkul. It was made to store codes, enabling engineers to carry out routines, repetitive tasks, etc. And it introduced the way of calling a subroutine from one routine. So you have this central orchestrator that's calling other subroutines in your code, just like maybe most of our systems running today. That's not on microservices, of course. So that's the kind of the central part of the event-driven part, is the lack of the central orchestrator. So this might be like the single orchestrator might be what we call the classic monolith, which has the whole code base tied together. And then we got this new modern microservices in the cloud emerging through the 2000s, starting in early 2000s. And the question is, are we now ending up doing a full circle? Because let's take a look at what articles are talking about as the new and hip and cool of 2024. It's the rise of the modular monolith. It's a new approach to software architecture. It's the microservice killer, the modular monolith architecture. But if we're diving into what is this modular monolith, they're generally talking about the separation of concern within your code, to have your code modular, to be able to change one part of the monolith without touching the other. But hasn't this kind of always been the best practice of programming anyway, though? Isn't this what we actually tried to do even way before this? So what is then the modular monolith? It's different from what we had in the 40s, we promise. But when everything comes around, if monoliths grow too big, it might be time to transition to microservices. I'm just to have that said, I'm not shaming any of these authors. They're doing a great job. They're just playing a good part in my storytelling. So, if the microservices is nothing new, we find it in the 80s, where the old people come from, like myself. What about the event triggering, though? Is that something new, exciting, almost like the Rube Goldberg machine, just a little less linear? So let's explore the magic of event-driven programming in C#. Or is it more of the resurgence of event-driven architecture? It's fun doing the history lessons, isn't it? I love going down those rabbit holes. But if you go back to the old days of real-time graphics and GPUs, when they started to emerge, this is a machine called the Whirlwind. They created a set of data points. They had this screen representing the eastern coast of Massachusetts. And then when data was received from the radar, a symbol representing the aircraft was shown on the screen. But they needed a way to kind of interface with the systems. So you see the thing he's holding here is called the light gun or the light pen. It was a way for them, for the operators to request identification of the aircrafts on the screen. So let's see what the historical article says about this light gun. It says when the light gun was pointed at the system for the plane on the screen, an event was sent to Whirlwind, which then sent text about the plane's identification, speed, and direction, also to be displayed on screen. This was 1945. But other than that, events are pretty tightly coupled to microservices. Of course, you can use them in your monolith as well, but then why? Why is it a monolith? So let's jump over and looking at some examples of how to use this in kind of a real life. Trying to wrap up a bit. So, when to use microservices and when to use the monolith? And will the modular monolith replace microservice architecture? That's a question. How neutral should I be in answering those questions? Because as you might have seen so far, I might be a bit biased. There is, though, a couple of situations where the monolith can give you some advantages. I will give you that. I'll even list them for you. It will be a lot easier and simpler operation and support. You have less APIs since data flows internally. You'll have less overhead and definitely less latency, if that's crucial. Your infrastructure cost will be much lower, and maintenance will be more. It's easier to budget for your maintenance because you kind of know what you have. And then like native data sharing, dashboarding, reporting might be easier. And also if you kind of don't know where your application is going, it might be a good place to start. I would not. I think all of the pros is at the cost of worse scalability, and any later modernization and changes of needs. You have to change your infrastructure. So in my opinion, and please challenge me on that, I can take that discussion as well. I would say the disadvantages of the modern monolith, no matter how modular it might be, is so high that I would rather not consider it an option. But again, challenge me. I'm open for a discussion. I'm free all day. I'm even here until tomorrow. So but my take on this, though, is if you're unsure on how to run your microservices or how to handle the infrastructure, how to handle the messaging between your microservices, it is actually not that hard. I was pretty late to the party coming to things like Kubernetes. Actually, very late this year. This year late. I've only been on managed services before that, but managing a team that is running everything on Kubernetes made me realize I really should understand what this is and how it works. So I set up my own cluster at home, and within a couple of days, I had pretty good control of how to fix my services, how to fix my ingresses, how to fix my deployments. So it's not as hard as you might think. And like the simpler mini versions of Kubernetes, like K3s, micro Kubernetes and stuff like that, can run on almost anything. Dig up an old computer at home or a Raspberry Pi or anything. I'll come to drop by a couple of other alternatives as well a bit later. Because building this for a future flexibility and scalability will very rarely come and bite you in the butt, but I think the opposite quickly will. When the monolith might be a quick way to the target, you're kind of building yourself into technical depths. That's my take on it. So I mentioned in my abstract as well something about master data management's role in the event-driven architecture. So by handling metadata in your queues or topics or whatever, the good old master data platform can make available topics or queues or whatever to update data, and then the rule sets can still be in the old platform, and as long as that also publishes the changes to any topics, and then other systems can stay updated, and even use, like if you have your Kafka running, you can have golden records that kind of keeps a copy of the truth, which makes it easy for new systems to backload on deployment, on corruption, on updates, on anything. So then the data ownership can still be handled within the MDM platform, just like you're used to. And then you can also keep a track of your lineage will be documented by the metadata if you do it in the right way. But then everything will just flow, and it will make it so much easier for you to onboard new systems, sunset old systems, and now I'm really getting into advocating for integration platform, which has been my field of expertise for almost 20 years. But that's another speak. I've held that before. I can do that another time as well. If anyone actually read my whole abstract for this speak, it was something about some microelectronics. They did not survive the flight. That was my fault. But let me say some words about what's really useful to take a look at and what can be fun and interesting to dive into to learn event-based architectures and have fun along the way. I love microelectronics and stuff. It's cool. Something called LoRa. It operates on, in Europe, 868 megahertz band. Is a long-range, low-energy communication band. The theoretical range is 15 kilometers. So if you put your gateway on top of a big building, you can have it all over the city. It's really cool. I read about one guy that made his LoRa device with this tiny antenna, and this is like maybe 3 centimeters long, the whole thing with the microcontroller as well. Put it in his freezer in the basement and started walking away from his house and still got at least 6 or 7 kilometers of range still. And then you can set up a mesh of LoRa gateways and servers, and you can have your application server in the middle. It's a lot of fun. Then you can even run NATs on your edge devices as well. That's really cool. NATs was originally just a message queuing system for kind of IoT devices and stuff like that. It's written in Go, actually, and is made for edge computing. So if you're working with edge computing, small devices, microcontrollers, maybe like isolated systems as well. This is something to look at. Then in updated versions, they added what they call Jetstream, with added persistence to any topics or queues. And suddenly you have almost like a Kafka instance running on your edge. They support everything from persistence, at least once delivery, exact once delivery actually as well. And can also be like set up in a cluster and have those leaf nodes, so it works. Any client can be a leaf node for the whole network, so it's kind of this mesh thing. And then you can run everything on stuff like this, an ESP32 thing. It's like $3. With Wi-Fi and Bluetooth built in, you can have some 4G shields if you're deploying this in remote areas as well. A lot of libraries, huge community working with it, so a lot of fun. So I mean, start with something easy and fun. Make your own weather station. There exists LoRaWAN power plugs, so you can control your power from far away. Use that with motion sensor or daylight sensor or whatever. Or get your moisture sensor, connect your plants and make your partner happy that you're not killing off all the plants in the house. And I mean, a lot of these are events, and you don't think about it when you're working with it, and that's the fun part of it. So yeah, as I said, the NAT server can run on everything. Put your old Raspberry Pi 2 to some use somewhere with the server as well. So I have a tendency to have a lot of fun along the road. So I'm not reaching my finish line. I had a question in my topic. That was, from SMS to now, why it still matters. It's kind of, we had this discussion in the open spaces yesterday, where we talked about certifications. And as I said then, I like the ride, I don't care for the price, but let's try to get to the end of this. So why does it still matter? Why are events and microservices still relevant, even if it's kind of always been there? And as I said before as well, it offers flexibility, it offers scalability, it offers a faster rate of deployment and patching possibilities, among a lot of other reasons. So it will not be just sunshine and rainbows, but I would say it's even easier to set up also in your home environment. Your computer at home can run Kubernetes. An old computer that you had at the old employer or whatever can run these services, and it's much more fun just playing with it than have to do it. We're actually getting to the end, even before I thought. I said we went through almost 60 slides on this time. I generally plan for a bit over 1 slide per minute for my presentations, and usually ends up pretty good. I never practice them. I write it, and I know what I'm talking about when I'm coming on stage. And generally, we're within. Any questions? Anybody want to challenge me in the no monolith questions, or about what we did a long time ago? Or I've learned who has the first question.